Hello, everyone. I'm Dr. Sharif Muhammad. We're living in a world that's just drowning in data, right? There are studies and research papers everywhere. So how do we figure out what's actually true? Well, today, we're going to put on our detective hats. We're going to uncover the exact process that experts use to slice right through all that noise and get to the real, reliable answers.
All right, so here's our game plan. We're going to break this down into 5 key stages. We'll start by figuring out what a systematic review even is. Then, we'll map out our investigation, go on an evidence hunt, screen what we find, and finally, put it all together in the final report.
Okay, let's dive right into part 1, the case. So what is this thing we're talking about? What is a systematic review? And honestly, why is it such a big deal?
I mean, really think about it for a second. We're bombarded with new research every single day. One study says one thing, the next says the complete opposite. It's a lot. For doctors, for policymakers, for you and me, this information overload is a massive problem. So the big question is, how do we separate the real signal from all that noise?
Okay, so there are basically 2 ways to tackle this. First, there's what you might call the easy way, a narrative review. This is where an author kind of just picks and chooses articles they like, maybe ones that already support their opinion. It's descriptive for sure, but it can be super biased. But then there's the detective's way, the systematic review. This is the real deal. It uses a rigorous, methodical plan to be as comprehensive and unbiased as humanly possible. Honestly, it's the gold standard.
All right, on to our second step, the blueprint. Look, any good detective knows you don't just run out the door and start grabbing clues. That's chaos. You need a plan, a solid blueprint that maps out your entire investigation from start to finish.
And this right here, this is basically our roadmap. Now, I know what you're thinking. It looks a little complicated, right? But trust me, it's just a step-by-step path that takes us from our very first question all the way to the final manuscript. Let's break down those first few key steps.
Everything, and I mean everything, starts with having a crystal clear question. And to get that clarity, researchers use a really cool tool called the PICO framework. It's an acronym that forces you to be super specific about the patient or population you're looking at, the intervention being tested, what you're comparing it to, and the outcome you're hoping to measure.
Okay, let's make this concrete. Let's open our case file on the Ebola vaccine. Imagine we want to know, is it safe? Using PICO, we can sharpen that question right up. Our P for patient is healthy human subjects. The I for intervention is, of course, the vaccination itself. The C for comparison would be a placebo, and the O for outcome is what we're measuring, safety and any adverse effects. See, suddenly our vague question is incredibly focused.
Next up, we have to set the rules of our investigation. Basically, what evidence gets in and what gets thrown out. The inclusion criteria spell out exactly what we're looking for. In our case, any clinical trial on Ebola vaccine safety, period. Then, the exclusion criteria define what we're going to ignore. Things like studies on animals, or opinion pieces, or articles where we can't even get the full text. Setting these rules up front is absolutely crucial to keep bias from sneaking in.
Okay, our blueprint is solid, the rules are set, now it's time for the evidence hunt. We are casting a wide net. The goal here is simple: find every single piece of potential evidence out there. We're leaving no stone unturned.
And just to be clear, this is not your average Google search. Oh no, it's a really meticulous 3-step process. First, you build a super powerful search strategy using terms from your PICO question. Second, you run that same search across a whole bunch of different scientific databases, like PubMed, Scopus, Cochrane, to make sure you don't miss anything. And finally, you dump all those results into one place, usually a reference manager, to get rid of all the duplicates.
And here's a pro tip for any good scientific detective. You register your plan publicly before you even start searching. It's called registering your protocol. Why do this? Well, it's all about transparency. It shows the world exactly what you plan to do, and it also prevents 2 different research teams from accidentally doing the exact same work at the same time. Super important.
Okay, so we've cast our net, and wow, we have hauled in a ton of potential evidence. Now comes maybe the most important part of the whole process, the interrogation. It's time to sift through this mountain of information to find those few nuggets of pure gold.
So for our Ebola vaccine case, that initial search, it brought back 1,785 articles. Just let that sink in. That is a mountain of data. So
How in the world do you even begin to sort through all that?
Well, you do it with a system, a brilliant system actually, that's shown in this Prisma flow diagram. Think of this as a giant funnel. It visually tracks how we take that huge number of studies at the top and filter them down and down and down until only the most relevant ones are left at the bottom. So let's look at how that funnel actually works.
It all happens in stages. The first pass is just looking at the titles and abstracts. You can throw out a lot of obviously irrelevant stuff right away. For everything that's left, you do a deep dive. You read the entire full-text article to see if it really matches our rules. Then you do a little extra detective work. You check the reference lists of the papers you've included, just in case they mention a study you missed. And for every single study that makes it this far, it gets one final interrogation, a quality check, to see if it has a high risk of bias. Only the strongest, most reliable evidence makes it through.
So, after all of that, after that intense, multi-stage filtering, how many are we left with? Out of almost 1,800 articles, we are down to just 32. That's it. That huge drop really shows you how tough and methodical this process is. These 32 studies are now the heart of our case.
All right, we found our high-quality evidence. The interrogation is over. It's time for the final step, building the case. We need to take everything we've learned from these studies and synthesize it into one clear, powerful final report. So how do we do that? Well, first, we pull all the key pieces of information from those 32 studies and organize them, usually in a big spreadsheet. Then, to make sure we didn't make any mistakes, 2 or 3 other reviewers double-check all that data. After that comes the heavy lifting, the statistical analysis. Often this includes something called a meta-analysis, which is a fancy way of saying we statistically combine the results of all the studies to get one powerful overall answer. And finally, you write it all up in a manuscript that lays out the entire investigation step by step for everyone to see.
And there you have it. That is the detective's guide to finding scientific truth. It's tough, it's transparent, but it is an incredibly powerful way to find real answers in a world that is just full of noise. So now that you know the blueprint, it kind of makes you think, doesn't it? What important questions would you want to investigate?